think we just had a moment as far as they're all solved the same way. Can we go in order? Because I think we'll see things build up. They get a little more intense as we go down.
Sure.
So let's just go in order if you don't mind, my friend.
Sure.
So go ahead. Grab the next 2 times the quantity x minus 1 equals 14.
Okay, well I just multiply the 2 times what's in the parentheses, x minus 1, so that turns into 2x minus 2.
Let me see a show of hands real quick. Who did that exact thing right there? Distribute your product. Almost every single one of you. Okay. Well, I want to come back to that. Love it, Chad. Now, do you see how this is that problem? This problem. This equation is that equation. Not literally, it's different numbers. But the same process applies, yes? The same process applies. You then undo what has been done. We'll try to read your mind, Chad. You added 2 to both sides. Because we knew the last thing that happens here is subtraction of 2. Which means the first thing to undo it is going to be to add 2. So we get 2x equals 16, and then divided by 2. There you go. Now some of you are going to say, first of all, is that similar to what those of you that distributed the 2, I'm guessing that was a similar set of moves that you guys used. I'm guessing. I challenge you to solve this equation in 2 steps. Because the thing is, we didn't quite use that Lego rule that I just described to you. We did an intermediate step, didn't we? We distributed the 2, which is kind of breaking the simplicity of the Lego rule. Whew. There is a way to use the Lego rule and solve this thing in 2 steps. And the reason I'm not saying that just to solve it in 2 steps, blah, blah, blah. I'm saying that because you can actually follow the Lego rule exactly, which means this is me sitting on the floor with my son with the wrong gear. He says, "Dad, fix it." And I go, "Okay." So, undo that for me. Tell me your name in the back of the hat. Go.
Oh, I was just...
You were pointing. I saw you pointing.
I wasn't like...
Sorry. I'm like an amphibian. I see motion. And you moved. And I jump on that. Sorry. Aaron, go.
Were you going to divide 2 first?
Why would you divide 2 first?
Did you get rid of the parentheses?
But why would that work mathematically, like, legally?
Because you're multiplying, so you have to
You're
divide.
eliminating the first step.
Okay, I like that answer. At some point you have to, but why the first step? Build this expression from the x for me. If you were an x value that you were plugging into that expression, what would happen first? Let's suppose, I'm going to guess, x equals 12. I want to see if 12 works. 12, what happens first? Y minus 1. Because it's in parentheses. Order of operations says that happens first, right? So the first thing we did was we subtracted 1. 12 minus 1 is 11, right? What do you do with that number? Multiply it by 2. So the 2 steps that we just accomplished were we subtracted 1 and then multiplied by 2. Can we undo both of those? Hell yeah, we can. The last thing we did was multiply by 2, so the first thing we're going to do is divide by 2. If you divide both sides of that by 2, you've actually done exactly the opposite of creating that side. If you divide both sides by 2, you end up with x minus 1 equals 7. Make sense so far? And the last thing we're going to do is to undo the first step. The first step, as you guys just told me, was to subtract 1. That means the last step has to be add the 1 over. So you end up with x equals 8. The reason I like that one is not because it's shorter. That's not why I like it. I like it because it exactly follows the Lego principle, yes? It exactly follows the Lego principle, which is undo exactly what has been done. That is what solving equations is all about. It's about undoing what has already been done. Something has been done to that one side of the equation. Undo it. Ask me that question.
Why aren't you teaching algebra?
I am, currently.
I know.
Because there's too many classes. Sorry. Ask me questions right now. Ask me a question I can answer. I should be able to answer that. It's light and refraction. Ask me questions about this process. Do you see how it applies to the next one? Now the next one involves the F word, not that one. Fractions. Not the one you often say doing math homework. Fractions. And as soon as students see fractions, they freak out. Another F word, they freak out. But you have to be able to deal with these things. I'm going to show you how to use fractions like this to measure the biggest pine tree around the Mazama field, hopefully on Wednesday of next week. And it involves an equation just like that. So I want you to make peace with this. Make peace with this, because fractions are part of life. So what a lot of students do is they look at that, they get tight, they get tense, they want a glass of wine. But realize just look at the side the variable is on. X over 2. Think about what that is. What is happening to x right there? What is happening to x right there? Please, Michelle. It's being divided by 2. I want to undo that. So I need to multiply both sides by 2. It's a very simple Lego move, isn't it? I put the gear and I put the axle, and Max goes, "Dad, stop right now! It was the wrong gear." Oh, pull the axle out, fix the gear. It's that, it's one step. It looks much worse because that's fractions. Blech. But that's okay, because it's just one little move. You simply multiply both sides by 2. So x over 2 becomes x, 6/7. It's a fraction. How do you double a fraction? Well, you could literally double it by writing it 6/7 plus 6/7, and that's what doubling is, right? Adding another one to itself. No, we don't like that? Oh, well, can we just, okay, we don't like that. So what is it? 12/7. If you got 6/7 here and 6/7 here, you have 12/7 altogether. The sevenths, and I think this is just a factor of the way fractions are put together. The denominator is simply a size of a piece of a pizza. So that's a pizza that's cut up into 7ths instead of 8ths, which is what Sibelius does, and all the because 8ths is simple. 8 pieces. 7's harder, but it's still just the size of the slice. If one of you has taken 6/7 of a pizza and another one has taken 6 more 7ths, then you've together eaten 12/7 of pizza altogether. Just shy of a couple of them. Another way to deal with it, if you hate fractions, which I know a lot of people do, what could you do with the 6/7? What could you do, Michelle?
I despise fractions.
That's okay.
They don't like me either.
They're not judgmental. Watch that.
I actually multiply the 6 times the 2 divided by the 7 to the x.
Oh.
That's what I did.
Oh, I'm gonna move this over. This over. So, this is very, very clever. And I usually don't teach it directly because it's a special case, and it can only be used when you have. Does anybody know what it's called when you have an equation that has a fraction directly equaling a fraction?
Proportions.
Thank you. It's called a proportion. Literally, here's one too. This is also a proportion. When you have a fraction equaling a fraction, that is mathematically called a proportion. When you have that situation exactly, you can do what's called, I think students call it cross multiplying. Where you can do, it's called the means extremes property technically. You multiply the means and the extremes. So you can multiply the x by the 7 to get 7x, and the 6 by the 12 to get 12, or 6 by the 2 to get 12, and then divide by the 7 to get 12/7. 100% correct, Michelle, of course. 100% correct. But this is, I always try to keep the pulse on how students are digesting algebra. Y'all digest probability just fine. I think because it's new enough and because it's intuitive enough. When we start looking at special cases like that, that's when students, they start getting like overwhelmed. Like if you have a proportion, then you can do it that way. And it's true, you can. But then students ask, what if you don't? That's a great question. What if you don't? Then you default to the Lego method. Undo what has been done. You can always default to that. You can always default. That's the beauty of it. You can always default. Tell me your name. You're just moving. I'm sorry. I saw your fingers go like this. You're just moving, rolling the pen through the fingers. Okay, fair enough? Undo the side. Everybody try it right now on this one if you haven't already. Everybody try it right now if you haven't already.